Welcome back to the workshop. We want to take a look at the root test. So let's use the root test to determine the convergence or divergence of these two series. Again, for the root test, we want to determine if the limit of the nth root of the nth term goes to a number below 1 or a number above 1. The series under question will converge if we find a limit below 1, and it will diverge if we find a limit above 1. And we want to take the nth root of the absolute value of the nth term. So in this case, what we want to notice is that each of these terms is greater than 0 in both cases, so we don't have to worry about the absolute values. All right. Then we want to take the limit as n goes to infinity of the nth root of the nth term, n minus 2 divided by 5n plus 1 being raised to the nth power. Of course, very conveniently, this nth power and the nth root will cancel out with one another, leaving us with the limit as n goes to infinity of n minus 2 over 5n plus 1. We have the ratio of polynomial divided by polynomial, so we just need to double check on what the degree of each is. So degree 1, the degrees match, so it's just the ratio of the leading coefficients. So 1 divided by 5. Of course, that is less than 1, so we have that the series converges absolutely. The series converges absolutely by the root test. Excellent. So let's take a look at our next example. We have n factorial to the nth divided by n to the nth squared. Again, all of these terms are greater than 0, so we don't have anything to worry about with the absolute values. So we want to take the limit as n goes to infinity of the nth root of n factorial raised to the nth power divided by n to the nth power squared. Of course, we don't care where the n and where the 2 are here. We can swap those because a number raised to a power, where that number has a power, we multiply these powers together. So n times 2, 2 times n, doesn't make a difference. We can bring the n out, apply the nth root to the numerator and denominator to get ourselves that this is the limit as n goes to infinity of n factorial divided by n squared. Now, hopefully this is a limit that's familiar to us. If it's not, I believe that we considered it in another video. Otherwise, I would encourage you to, let's see, what could you use here? Well, some familiarity, I guess. With n factorial, certainly that's going to grow much larger than n squared. So this is going to go off to infinity. So we'll say that this is divergent. Our series under question is divergent by the root test. The series diverges by the root test. Excellent. I hope that was a little bit helpful. Again, if you have some questions about this, that would require a discussion on limits, but the main thing is recognizing that n factorial certainly grows faster than n squared does. So if you have any questions, feel free to let me know or do a little bit more searching. And I will see you guys back in the workshop very soon.